So this is part 284C3M1B7C8E13C9C6D3P38D19D7b34. Line 22f1fa19c3m1b7c8e13c9c6d3p38d19d7b34 RF sputtering plasma ZnO and then O signals 5G Wow Seti. There's the alien radio signal. This is where the data starts. So this is going to talk about PDF test results for radio frequency over glass, sputtering plasma, ZnO long distance signals device for a UFO, and the WOW data. So there's the line of data. And the previous video was about RF over glass sputtering signals, UFO, and we put UFO because it's something to do with the core, the engine part of it. Okay. So the keyword is Fonnula particles, wavelength formulas, and Compton wavelength. And then I brought up Fonnula units, tile mole 1472, and I googled that, and this is what I got a whole pile of PDFs. So I've broken them down into individual little segments to look at, okay? Just to make this short and sweet and to the point. So Vacuum Volume 59, Issues 2 to 3, November 2000. Proceedings of the 5th International Symposium on Sputtering and Plasma Processes. And there's their little book cover there. Optimization of zinc oxide thin film for surface acoustic wave filters by radio frequency sputtering. There's the name of our scientists, and they are from Kazawa, Ishikawa, Japan. And it's the dxdoi.org. I'm going to get rid of this. I don't need all this stuff here. Forgot to delete that. So the abstract is electrical characteristics of zinc oxide, ZnO, glass surface acoustic wave, SAW filters, and the structure of which is ZnO thin film on a glass substrate with aluminum interdigital transducers, are greatly influenced by deposition parameters of a radio frequency sputtering for making ZnO thin films. The deposition conditions for making the ZnO thin film are also considered to obtain good piezoelectricity for SAW devices. Oxygen concentration in the radio frequency sputtering greatly affects the properties of ZnO thin films. The interface and microstructure of ZnO thin films is investigated by cross-section transmission electron spectroscopy. The growth figures of ZnO on glass and ZnO on Al are similar. The average crystal size of ZnO on glass is larger than that of ZnO on Al. Figures and tables from this article. So it shows the substrate and the target and then to pump. And it shows gas and RF power. So this is a schematic figure of the RF sputtering apparatus. And it says deposition rate on the left side and the bottom oxygen concentration and percentage. So figure 2, deposition rate of ZnO thin film in RF sputtering versus oxygen concentration. The next graph here is intensity of AO. With 2 with 0, the line in the middle of it, straight across, degree. And then it's got some figures on the right here, which you need to take a look at. You can look at it on their blog as well. So figure 3 is the XRD result of ZnO thin films on ALIDT glass with changing atmospheric compositions of AR/O2. And then we show the length of the C-axis in nms from an oxygen concentration and percentage, and its figure 4 is the length of the ZnO C-axis versus oxygen concentration. So you can see it goes up. And then we have SAW velocity V5 versus oxygen concentration, and for some reason that one didn't come through. And then there's figure 6, sorry, attenuation TV. Group delay time ns and frequency at megahertz. So frequency characteristics of a ZnO/IDT/glass structure, SAW for Japanese television intermediate frequency stages. And then this one's the insertion loss and oxygen concentration. It says insertion loss of the SAW filter versus oxygen concentration. So it kind of makes it go straight across. And then it's insulating resistance. Again, it goes straight across and it curves up. Insulating resistance of the solid filter versus oxygen concentration. So I found that on the www.sciencedirect.com blog, and there's the link there. So I'm going to continue with the keywords Fonnula units in the next video. Thanks for watching.